So here's our first open-ended problem. We have a bunch of conditions here now typically are going to be on the first derivative and the second derivative. So as you can see, we're going to draw the graph, but we have to figure out information about the first derivative and the second derivative, right? So let's see. So I need to do my sign charts for the first derivative and the second derivative. You know what? I'm going to put it down here. The first derivative sign chart is pretty simple. There's only one point that they told us about, right? Where the derivative is 0, and that's the point at 5. Below that, you've got right, less than 0. Okay, so decreasing, and then above 5, we've got an increasing function. So, and we know that the derivative is 0 there, so we clearly have some kind of minimum there, right? F of 0, f of 5, right? So that's the first derivative. Now for the second derivative, they give you 2 points, 2 and 8, where the second derivative is 0, and then it is going to be negative on the ends and then positive in the middle. So we have between 2 and 8, we have a concave up function, and then it's going to be concave down on these 2 ends, and then we have 2 points of inflection. Okay. Now where are we going to put this on the graph? We can be, well, let's see, the last piece of information gives us something. It looks like we have a horizontal asymptote, and we're going to make this 3. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fine. Okay, so I'm just going to put it anywhere. It doesn't really 1, 2, 3, 4, 5. Okay, I know I'm going to have it below here, right? Because I am thinking that there's going to be this minimum, and then it's going to go up to this 1, 2, 3, 4, 5. So let's put this here. That's going to be my minimum. And then I'm going to have 2 points of inflection where my curvature changes from concave up to concave down, right? So here I'm thinking of the curve being sort of shaped like that, and here the curve is going to be sort of shaped like this, right? So let's see. At 2, I'm just going to put some points here. 2 and 5, 6, 7, 8. So like that. And then we'll just go like this. So here it's going to be concave up, and then it's going to be concave down. It's going to switch at those 2 points, and there's my graph. Okay? So that gives you some idea. You can see I could have made this a lot lower, or I could have made it a lot closer to this. It would have been fine. So I just sort of picked that there because I thought maybe it would like look better, you know. But that's pretty much it. So here's another one. We have, let's just get started with the very first thing. They did give you an actual point there. F of 0 equals 0, right there. Fine. Now, these are a little bit mixed up. I would put this one in with these. Let's look at these first. It looks like as I'm going out to positive infinity, I'm going to be approaching 0. I don't know if I'm approaching on the top or the bottom yet, so we'll just wait with that one. But then clearly I've got an asymptote at x equals 6, right? Whoops. Sorry about that. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Because I can see there's a 12 here. So some stuff is going to have to happen here. You know, it's got a big, I just need something a little bit big. So 1, 2, 3, 4, 5, 6. This is going to be my asymptote at x equals 6. And it is saying that the limit is minus infinity, but it's a limit from both sides. So it looks like I'm going like this. Okay, so probably it's going to go up here, but that might be doing something else. So yeah, because there's some information about something at 9 and something at 12. So let's just wait and see how that goes. So now we're going to go and do our sign chart for the first derivative. And there's a lot of information here. 2, 1, 6, 9, or negative 2 are going to be the points. So this should be negative 2, 1, 6, 9, right? So it is going to be negative here on below negative 2, between 1 and 6, and after 9. And it's going to be positive for negative 2, 1, and 6, 9, right? So we have 3 regions of decreasing and 2 regions of increasing. Now, we know that 6 is this, right? Asymptote there. And then we know that the other 3 points are actually going to be horizontal tangents. So we can see, okay, this is decreasing to increasing. It's going to be increasing to decreasing. So we're going to have a this guy, and over here, increasing to decreasing. So it looks like we have 2 local maxes and 1 local min. And I may have to erase this if I'm going to draw down there, but we'll just do this first, and we'll, deal with that when we get there. So for my second derivative, I have these 2 pieces of information, and it looks like the sign of the second derivative changes at 0, 6, and 12. So 0, 6, and 12, right? Of course, 6 is going to be still that asymptote. Let's see. So it's positive here and here, and then it's negative here and here. So I've got 2 points of inflection, and it's concave up here at the ends. Now, it doesn't tell me what it wants this to do at the end, so it doesn't really matter too much. So, but let's start over here, okay? So, and just kind of thinking about what this is going to do, we did say that it goes off to 0 over here, right? So, but I have my function increasing up to 9 and then decreasing, right? So let's, here's 6, 7, 8, 9. Let's put this up here so we can see it. And then 9, 10, 11, 12, let's put the point of inflection here, okay? So what we want is then we're going to go up and then down, okay? You can see how this fits with both of these, right? My function is increasing to the point at 9 and then decreasing after that. It's concave down to 12, and then it turns, so it's pretty flat, but you can see it's concave up for the rest of the time there. Okay, so that's what we got there. Now, let's not forget, I put this point on the graphic. We got to go through that. But we also have we also have a maximum at 1. And this point at 0, actually, the concavity changes. So let's see. My maximum at 1, let's just put that up here so we can see it somewhere. And so I'm just going to make that my maximum. Then that is going to go down there. Okay, so this makes sense. I have my function increasing. I'm sorry. Yes, increase. Well, it's increasing from 0 to 1. It's actually going to increase from -2. So I'm going to bring that down here somewhere in a minute. But I'm going to have to erase this. But we'll just talk about it first. So I've got this guy, it's decreasing from 1 to 6, right? Now this whole part is also from 0 to 6 is concave down. Now for the rest of it, this is my point of inflection. The rest of it's going to be concave up. So I want my function to have a minimum there at -2. So I'm maybe going to put that here. Okay, that's going to be my minimum. So I've got maximum, 2 maxima here, and then 1 minimum, 1 local minimum. I'm just going to take it down and then back up. So let me erase this for a minute because I'm in my way. But I'm going to now take my function down and then back up. So it didn't tell me. That's fine, right? I do know that I don't necessarily want it to have an asymptote because I don't want the concavity to change, right? The concavity is going to be, it's positive here. It doesn't have another point where it's going to go down and sort of flatten out. So I know that it's just kind of going to go up like that.